Cool. Remember, this is a working group batch meeting, and please follow the Kubernetes code of conduct. Let me go ahead and share my screen. We could take a look at the agenda. Um, 1 second. Alrighty, it looks like the first item on the agenda is with Kevin. Want to go ahead?
Yeah, I'll be relatively quick. I'll need to be able to share my screen.
Okay, let me stop share and figure out how to give you access to that. Are you able to share it all now or no?
No.
Okay. Um, all right. Are
I,
you
I
ready? Oh,
added I added
awesome.
permission
You can
to
teach me how to
Kevin.
do that later. Thanks, Yuki. Go ahead.
Okay. Yeah. All right. So I'm gonna go ahead and share. So what was I gonna talk about? Basically, we were talking about for the workload aware scheduling. I was what I wanted to start with is just kind of give an overview of what's going on like at least the job API in 1.37 to kind of show sort of what I'm thinking we need to do for Q. So I'm going to switch to my terminal. Basically, the idea that uh, like what we're going to start having on job APIs is a field called scheduling. And this kind of specifies so by default, we will not do gang scheduling. We will still create pod groups and workloads, but they will not be gang scheduled. They'll just be kind of normal scheduling as usual. And then gang means, that we're going to have the pod group and we require, and this is defaulting to the parallelism. So this is it's saying that the pod group should be all four pods need to be scheduled for this job. And you can kind of see at least for the gang that I created. This was created here, and I don't know, these names are long. uh, but yeah, you can see the gang is for this disruption mode. This is basically saying how we want preemption to happen. I guess by default, this would be saying that we would preempt pods one by one. We probably would want the preemption to be all or nothing, but anyway. And then pod groups also will have a priority on them, so you can kind of give different, basically different priorities to the pod groups for the scheduler. So this was sort of the simplest case for just gang scheduling. And then we have a similar one for topology where the idea is we can also specify gang scheduling and topology constraints to have our job, all the pods fall on the same rack. And yeah, and so basically what I'm kind of envisioning is for Q that like if a workload like job and like what we're really trying to encourage is that controller authors like job set, job, leader worker set will start adopting kind of the APIs in this way so that ideally all these APIs should have a field like scheduling, and this kind of can dictate like kind of the declarative way of saying how they want your workloads to be getting scheduled. And then for in job set and leader worker set, it's going to get more complicated because you could have sub gangs, but I'll talk about that probably separately later on once the composite pod group work lands. But basically what I wanted to like this is kind of what's going on in 1.37. This is still alpha. Uh it will be alpha on 1.37. The WAS and the pod group APIs will be going beta in 1.37. So this work is coming. So what I wanted to kind of maybe start sketching out is sort of our plan for how we can start thinking through this in Q. And I see at least a couple different areas that we have to consider. I know the second bullet point is more what I was talking about, where like I think probably what we would want is once the controllers have the scheduling field, we can read that to to make sure that the queue, well, now I'm thinking about it. Basically, if we want the gang scheduling and all that to work well, and the queue to admit, and then the scheduler to place as a gang, we would want to make sure that the queue workload, and the WAS workload and pod group are all kind of matching. So that's at least something I imagine we need to update in our job framework library once that is available. The other one that I've been thinking about is kind of like workload priority class, because now we don't just have priority on the pod level, we have it also on the pod group level. And I was trying to look at how do we envision this working with like the workload priority class, because we can have preemption happening from the scheduler preempting the pod groups, but we also have the workload priority class that can control that too. So that's definitely another area I think we'd have to think through. I also talked about, I think last 2 weeks ago, maybe one idea is having our when we don't have a controller controlling like pod creation like we have for the Q pod group, we could create the WAS pod groups for that one. And then the last, I guess this is more of like, I'm not sure the value for wait for pods ready if we have entry gang scheduling. So that's, I guess, something we probably want to explore. I think at best it's a safety hatch for just evicting workloads if they aren't scheduled. From I think we do is something similar. I have to check. But for the gang scheduler, I believe we have a timeout also when pods will stop scheduling, or if they don't get scheduled within a certain time. But yeah, that's kind of, and sort of what I was wondering here is like, how should we get started on all this work? Like, do we want like a large cap kind of sketching out all of this, or do we want to kind of have, like, obviously I didn't even talk about the scheduler library, but I know that just merged in 0.19, pretty minimal implementation from what I understand, but at least that's another area that I forgot to mention. Go on, Oleg.
Just wanted to mention that the first bullet on your list, integrating with schedule library, this is something we are already working on. There is Carol in our team. You may recall him from open source reviews and so on. So yeah, he has drafted a PR to integrate in Q with the scheduling library to get answers like, will this pod fit on these nodes given all the constraints that were so far unconsidered by Q code. I am working now on the next PR in this direction, and we are in contact with the WAS team as well, so that they like, yeah, they want to give us sufficient support for that. So this is already somehow taken care of, and Carol is also working on a cap, which he wants to publish once the draft implementation is enough ready that we understand what's hiding there, really.
Are the
Okay.
PIs public? Are they upstream?
The KEP I don't think is open yet, but the PR was merged.
Oh, okay.
But I don't know, was there, is it more like we brought in the dependency, or did we actually start using it in some places?
It is about using it deep in class checks. Like wherever Q does currently kind of manual checks, like let's go over node labels and match against label selector, let's go over node tains and check if they're satisfied. Our goal is to replace this with, as the first step, with the library checks. Yeah, scheduling library, please tell us if this pod is fit to run on this particular node. Then the next step would be to also give the library better understanding of pods that exist and are planned to run, so that the library can check various interpod affinities and such constraints that were so far ignored by Q.
Okay.
I don't know if Sohan or I went for it, but Sohan, go ahead.
Yeah, I think probably we might need to create an issue to track this stuff because on the scheduler library, probably I had to go to that repo to understand what's happening. I gave a couple of review comments on the initial draft, but it would be really helpful if somebody could draft an issue in queue. And we want to see how that is getting integrated and probably the conversation that is happening behind the scenes, just to get clear understanding where we are heading on the OS integration. Just to avoid stepping into each other's toes and probably might help in architecting some of the stuff because it's not only about WAS, but there is also DRS stuff that's happening and we might need to converge at some point of time. So yeah.
Okay.
And then I was just gonna plus one, Sohan. You said what I was about to say. Like there's for instance for dynamic quota orchestrator, I like that there's like a pinned issue. I know there's like a Google Doc of like plans of how queue integration would work. So maybe if you have like a high level one that you could turn into a GitHub issue, we could check off when like each large major component kind of like finishes. That'd be super helpful. Um, yeah.
Yeah, I can take. At least we can do like an umbrella issue, and then maybe have sub
Yeah.
ones for each of these ideas. It sounds like we'll probably go with separate keps for each of these little work streams. Then, if the scheduler library is kind of already gone that route, that's fine with me. And yeah, I guess like I know I'm having to answer a lot of questions internally about like WAS versus queues TAS because like we are only just starting to adopt topology aware scheduling, and I think there are some concerns. There's still concerns about like which like do we need to adopt queues TAS if WAS is coming, and so I know if I'm getting these questions, I think it's probably I know, and we're seeing it a little bit in the thread. So I think at least having sketching out this plan, I think is useful because I think we have at least an idea of how that will work, but I don't know if like I know I've had to explain a few times that like workload aware scheduling is not going to handle queuing, so queue is will still be around. Uh, but yeah, and I guess because like there is why it's coming up more and more for us is like we have some cases where people want to combine both uh like rack level topology and NUMA alignment, and they're using like uh their or NUMA or like GPU to NIC placement within the node, and they're using DRA to do that on the node. And it's kind of right now I don't know if Q's TAS doesn't would probably not really solve this that well. And so I know what Sohan's kind of talking a little bit about is making sure the scheduler library also hooks into stuff like TAS with DRA, which we don't yet solve. So, and anyway, go on. Working group batch number 1.
Yeah, so I think the for what's topology Java scheduling integration inside of a queue repository is the first blocker is the current scheduler side task doesn't support multi-hierarchically topology definition and assignment. They currently support only flat topology tree. So if what does can support the more complicated topology assignment mechanism, we can, I guess, we can delegate queue topology assignment mechanism to the scheduler code. Otherwise, we have to keep the current queue topology aware scheduling mechanism inside of queue repository. So the question is, so can Cube Scheduler support the multi-hierarchy topology assignment from performance point of view? I guess So previously, SIG scheduling was concerned about scheduling performance when scheduler support complicated topology assignment. So I want to catch up the current opinion for that inside of the Cube scheduler maintenance team.
Yeah, I mean, I think it's gonna be iterating. I think like I don't know if the TAS will fully solve everything we need from Q right now. I also I'm not as following the topology or scheduling side on Q. I'm more just focusing on like the what it's gonna look like at the workload level.
So is there sorry, go ahead.
I mean, they have a long roadmap, and I imagine the Google folks here probably know what the plans a little better than I do. But I know that like they are concerned with feature parity with Q's TAS, so I think they're probably aware.
All right. So yeah, I guess there's no public updated information for now. Yeah. Go ahead, Michal.
I think I can pretty much update you on most of the things that we talk internally about the integration, because we are going to basically progress it. And as Paweł Kępka is actually like the TL inside Google, who is responsible for the integration, like the high level. So he's not like very active. Maybe he's a little bit active, but for example, he put forward the doc, the high level design and the main challenges and like steps for the integration. So indeed, there the idea is like two major streams. So one would be the scheduling library, and the other one is the integration with the APIs. So why we think the scheduler library is still needed is because Q, in order to do so, as Kevin mentioned, like queuing stays in Q. So, but at the same time, Q needs to know whether the workload is ready to be admitted or not. So it needs to be also aware of the topologies. So what we want to do is basically run the scheduler library code to do the task placement for us. And this means that it's not just task placement, but it's also like comprehensive scheduling placement. So it should, in principle, respect also the array constraints. So yeah, that's our idea basically. And we want to do this like we considered alternatives. Maybe this thought process was not totally public, but we also considered alternatives or talking not by compilation but by APIs. But the problem here is that we need to have preemptions performant. So Q at scale can execute thousands of preemption simulations. And we were not able to figure out in any other way rather just by compiling in the scheduling code into Q and use it to simulate the preemptions. So yeah, that's the main work stream we envision. And then for the parity itself, I don't think this is a major discussion point. Actually, the idea inside VAS, I think, is that they will put entry points into the task inside VAS algorithm, where Q will be able to customize the algorithm. So Q will be providing, in a way, plugin or extensions to the algorithm. So and because this is all in one binary, then we can, for example, read all the APIs, etc., from the workload objects. and use this information into the injection inside the injection points. We can also use like fare sharing information and additional information inside the implementation of the injection points. So this integration via the scheduler library allows us um, uh, to utilize the kube scheduler solution for the DRA and better scheduling accuracy. At the same time, it doesn't really require feature parity. What it requires is the extension points, which will be expressible enough for Q to express our task logic. Yeah, so this is at least my current understanding. And then another work stream is the integration with the APIs. So as Kevin mentioned, what would be nice is, for example, if Q can read the Kubernetes workload objects, and so that users don't need to specify the topology constraints on the pod sets, but they can use the or it would be like an alternative for the users to specify the APIs on site on the job objects. What is the gang, etc. So this is at least like high level understanding for me of these two work streams.
Yeah,
And
and
yeah, as I say, just one last thought is that maybe if there are some confusions, etc., of how this can work, then it would be good to organize or invite to the next meeting Paweł Kępka. I think he has it thought through pretty well, so maybe he can answer more questions then.
yeah, I mean, I think part of like we'll need like a sketch of like a plan maybe in queue of like where this is going, because I think it was Amy, other working group batch, that also said that like we are getting people that are kind of looking at this and wondering like, should we just wait on like Q's TAS because WAS is coming, or like I don't really want to use Q because all I want is gang scheduling. And so like what I imagine, like what I'm seeing more are from like our inferencing folks, they're more pushing for having this stuff on the API for their workloads and not really trying to adopt something like Q. And so that's where I kind of see at least what's happening for us right now. I mean, obviously, what we're having to say, TAS is the only thing that's mature enough. Sorry, Q's TAS is the only thing mature enough to get topology and gang scheduling within the next like 6 months or a year, for us at least. Maybe for you all, it's a little faster. We're slow in Red Hat land. But that's at least kind of what I'm telling people. But I know that uh, it's still probably a lot of people are answering these questions, but it's also WAS is a little confusing and there's a lot of stuff going on. Anyway, sorry, I'm talking a lot. I'll let Amy go.
Yeah, just as like a work next thing, can you, besides joining the next meeting, can you have Powell also work with Kevin on the umbrella issue? Because I know like it's good to just like pull things out of Google Docs and like actually put them in the repo itself for us to track. And that way also he has like partial ownership of the umbrella issue as well. So that'd be super helpful. Cool. Is there anything else people want to say about this topic? Otherwise, we can move on to Marcin. Okay, let's go ahead and move on to Marcin. I think your bullet point was new preemption API.
Yes, could you please give me the co-host privilege so I can share my
You could
screen?
do that. Yeah, thank you.
Yeah, I give permission to you right now.
Thank you. Okay, can you see my screen?
Yeah, I can see your screen.
Okay, so for quite a while we were postponing a number of feature requests and problems around preemptions. The current preemption in Q is somewhat limiting. So it's based on enums. So you can have either no preemption or preemption of workloads of equal priority, lower priority, equal or lower. You could specify similar things for reclamation, and that's more or less it. If you need anything more complex than simple direct priority-based preemptions, you need to hack it around, possibly using fair sharing, possibly using multiple and complex cluster queues. Anyway, it's not that easy to get anything more than it. And that becomes particularly problematic in case of defragmentation and fragmentation of the cluster. So let's imagine that we have 3 cluster queues in the cluster, and in cluster there are 8 nodes allocated in 2 racks, for simplicity called rack A and B. The cluster queues are green, pink, and yellow. All cluster queues have nominal quota. Pink has 1 node, yellow one has 1 node, and the green one has 4 nodes. As you can see in the first part of the image, both pink and yellow are running some workloads inside of separate racks. Both of them are perfectly within their guaranteed quota. And then comes a workload from green cluster queue that has 4 pods, each requiring a single machine. Green cluster queue has a quota of 4. So this workload should be guaranteed to work. However, due to fragmentation, it cannot start because green one cannot preempt pink inside of its guaranteed quota. Green one cannot also touch yellow one, and as a result, the green cluster queue cannot use their quota if the workload has any topological constraints. And you cannot allow it to preempt yellow workloads because the current set of rules doesn't allow for that. If for some reason a preemption of yellow workload in favor of green one would be allowed, then the green one could get into, for example, rack B, and the yellow one could be restarted in rack A, and everyone would be happy. Current preemption configuration is also limited in other aspects. So a while ago, I sent a design for Uber cluster queues and hero jobs where Uber cluster queues could preempt workloads from other cluster queues in order to accommodate bigger workloads that will occupy a significant part of the clusters, and individual cluster queues would not be allowed to get these the preempted workloads back because Uber cluster queues hero workloads would not be preemptible. We have heard multiple requests for non-preemptible workloads, and when we drilled into details, then non-preemptible workloads had an asterisk. The users wanted workloads to be non-preemptible, but maybe for super high priority workloads that would allow some preemptions. All in all, none of these use cases were easy to be configured using the current setting. None of them could be solved with adding yet another enums because users that we talked to were quite opinionated about who they would like to preempt for defrag, who would they like to preempt for hero jobs, which workloads should be non-preemptible, and on top of that, they had a couple of other crazy ideas. So as a result, we are thinking about introducing custom user defined rule sets for preemptions. And these rule sets would have different triggers and would allow to specify who could be preempted for what. The idea is to create a top-level object called preemption strategy that could be referenced by cluster queues. Inside of this preemption strategy, there would be preemption rules and ordering. Preemption rule would specify who could be preempted to accommodate who if a specific trigger is happening. The trigger could be no quota or quota borrowed or insufficient topology. If any of this trigger happens for selected set of workloads within a cluster queue, a set of candidates would be selected based on specific criteria, and these candidates would be then sorted using the ordering specified in the preemption strategy spec and evaluated in a similar fashion as we currently evaluate preemption candidates. Each rule would allow to specify which candidates we may want to select for that specific rule. And selector allows specifying multiple aspects of the candidates. We would be able to specify the relation of the candidate to the preemptor, whether they are in the same cluster queues or in the same cohort or maybe same same cohort tree, or maybe they are just in the same cluster and they are not in the same cohort. We would be able to specify what are the quota constraints, whether the candidates are in a cluster queue that is borrowing quota or their cluster queue has lower DRS. Selector would allow to specify which cluster queues should be selected. Maybe some cluster queues are more privileged. They are, for example, Uber cluster queues and should not be touched at all. Would have a selector for host nodes to limit preemptions only to specific set of nodes, to specific to workloads that match specific selector. On top of that, we are thinking to allow priority expression that would allow to specify which set of priorities could preempt what, and allow users to or system administrator to specify things around execution time and time for creation. For example, system administrator may want to avoid preemptions within the first 10 minutes or 20 minutes of the workload running, or that they would like to preempt candidates that have been around only for a day, and if workload has been waiting or running for days or weeks, then it should be given more courtesy and should be allowed to run. All of them would be placed in the preemption candidate selector that would decide which candidate should be selected for a specific rules. Inside of candidate selector, all rules are connected with AND. In preemption rules, individual candidate selectors are connected with OR. Okay, any questions for that part?
Wait, can you go back to the last slide again?
Sorry, which one?
I think there was one
This
after.
one?
Yeah.
This one?
Uh, so is the idea for this API to replace the existing like like way that we do preemption, and then now this applies to everything, and then we have like a special toggle for like things where we want to preempt that's within other people's nominal quota?
Yes, so the idea is to allow users to specify it instead of our current enum-based preemption rules. I will go into implementation details in a moment. But the thinking is that cluster queue could reference preemption strategy, and this preemption strategy will work as the only preemption strategy and would replace the existing defaults regarding preemptions. So there will be a field in cluster queue, preemption strategy reference, referencing preemption strategy, and if this field is specified, then the preemption pointer should be nil. If we are talking about like low-level details.
Yuki, did you want to go?
Yeah. So will we deprecate the current classic preemption and fair sharing preemption after we introduce this mechanism?
I'm not sure if we want to deprecate it. So there are a couple of options. Either allow the existing API to be used because it's simple. This set of rules is complex, and it provides multiple ways to shoot yourself in the foot. So probably it should be modified only by advanced users. Internally in the code, we would base everything based on this API and will translate the current existing API into this preemption strategy. So that in the code, it will be based on this thing, but for the user, for simplicity, we may want to keep the old API, or we could bundle Q with pre-populated default strategy. Again, it's like more or less equivalent options, and that will be definitely like rise in cap so that the community could express their preference.
So in that case, so regardless of deprecating the existing API or not, we don't allow users to specify both
We
current
don't allow
request classic
specify
and
both
yeah,
because
okay.
it would be hard to understand the intent. So it's either or other option deprecate the old field and force everyone to use this extensive API, possibly relying on the bundled default.
Yeah, so the main concern was how to keep compatible between the current preemption policy and this new policy. But so you mean so we don't support the combination policy at all. So
Yes,
yeah, we don't.
no
I don't have.
combinations.
Yeah, I don't have any objections to introduce new mechanism. Yeah, let's create a cap and maybe use API and the mechanism details.
Okay, any more questions for the candidate selector or preemption strategy? Because there is a second part.
Yeah, I have one more question and then we can move on to implementation. Can you go to the previous slide?
Uh,
Just like on your comment,
this one?
yes, just on your comment of like, yeah, like especially like the priority expression, in terms of like, yeah, users being able to shoot themselves in the foot. Like when it's like around priority, like users like abuse that a lot. So I'm just saying it'd be cool if after you guys implement this, if there's best practices you can also publish, or maybe like guardrails, especially around priority on like the cluster queue level. Yeah, I'm not sure, but we just basically don't
Yes,
want it to turn back into a global queue, right? Where it's like like everyone squeezes in for the highest priority level and then everyone else sort of gets preempted underneath that. Um,
definitely these things will require extensive documentation with lots of warning boxes what will not work. For example, it's quite easy to create like a flapping workloads if you allow everyone to preempt everyone on any occasion. Then obviously mm, each cluster queue would be able to preempt everyone, and in the next scheduling cycle, the workloads will get back. We could try to catch some very obvious uh, things like empty preemption, candidate selector, or whatever, and warn the user that this is likely to create flapping. But in general case, we cannot completely prevent them from accidentally shooting themselves in the foot.
yeah, I just know for like large enough and complex enough organizations, they don't necessarily know how scheduling works. They're just more like, oh, this is like we grant you capacity from provisioning in like a P1 thing because your director or whatever says it's important. Um, so yeah, basically just looking forward to your guidelines and documentation on that. All right, that's it for me.
We can also try to make the documentation uh, LLM friendly so that someone can uh, paste their preemption strategy and provide the link to it and ask LLM to validate it, whether this thing looks suspicious or not suspicious. Programmatically, it's relatively hard to catch all the cases where the user is shooting themselves in the foot. But yeah,
Yeah.
we'll try to provide as much documentation and best practices as possible.
Like basically you need to be able to turn this into an organizational capacity venting policy to people that don't do scheduling, right? Like capacity organizations are like divorced from the actual like infrastructure often, is sort of like what I mean. I think Daniel has a question.
Yeah, this might be a daft question, but I was just wondering if you couple this concept with the idea of attaching a tier to a workload, like imagine like the top priority tiers could be 0, lowest priority tier could be 5, and everything in between. And so then you could say if um, at tier 5, a low priority service could never preempt a tier 0 service. And if you have that kind of framework, then organizations would kind of have to justify why a workload belongs to a particular tier. But once you're in that tier, then you have the privileges of like preemption capabilities that go with that tier. Something along those lines.
Sorry, is that a question for Marcin or uh
No, yeah, pretty much. Yeah, just food for thought.
Okay, I missed the question part. I totally agree that like tiering workloads and make it easier to understand in the organization is a good idea. Is there any specific question
Oh,
that?
sure. Yeah, whether the idea of a tier, if you couple the tier to what they're allowed to preempt, like you were thinking about when you're
Yeah,
thinking about
so
guardrails.
uh, right now we have like workload priority classes that is kind of a tier already. So with this design, you can also have tiers based on the workload labels or nodes that they are running. So uh, all of the selectors could be configured in the way you like. So you have fine-grained control over who is uh, uh, mm, candidate for what workloads.
So that gives you like a nice framework, so that not it doesn't become like a wild west of anybody just can preempt anybody, but you already have like a nice framework where things can be done in a more thoughtful manner.
Yes, and this is to be as this is like a cluster scoped object referenced by cluster queues. It will be configured by system administrator who hopefully has some knowledge about queue scheduling and what this API is all about. The users will behave as they used to be. They may have some extra powers if, for example, if they label their workloads in a specific way or they use a specific priority, but they won't be able to modify the overall system behavior, which is in the system administrator way. System administrator hands.
Yeah, so I think to Amy's point, it might be nice to kind of say, hey, here's an example of a framework where you have tiers, and these tiers kind of have the preemption privileges, and how this could work in a very thoughtful and governed manner so that you won't get yourself in trouble. Just as an example, obviously it could work like you build it so flexible that it could be work in any number of ways. But here's an example of how you can think about doing it in a way that won't get you in trouble, to Amy's point.
Okay, yeah, sure. Very good idea. We'll do it.
Cool. Let's move to implementation.
Okay, before that, there is also one more thing. So, especially in defrag, you probably don't want to be defragging all the time, everywhere, for every single occasion. So, we are thinking also about introducing limits to preemptions, either on the global level or individual cluster level, or possibly even workloads. So that you can say, well, globally, I don't want to have more than 20 defrags per minute. Or this cluster queue can only defrag defrag others once every 5 minutes or so, so that you have some safety controls when you will be enabling important features like defrag. Without limits, it's kind of leap of faith. So you enable defrag, and 3 minutes later, your cluster is completely wrecked. With these limits, you can gradually enable defragging. For example, first allowing 1 preemptions per minute, maybe 2 preemptions, and see how it goes and whether the things is looking good, and then maybe giving more generous limit for defrag. Okay, and implementation and observability. For we would be adding explanation to all of the preemptions. So if a workload is preempted based on specific rules, the preemption it would be included in the workload condition, like explaining why the hell this thing was preempted and by who. And the rule names will be also included in the metrics so that you can count how many defrags and how many other preemptions happened in the system. Implementation. So this thing is big. So we were thinking about the following approach. So as a first step, do it internally only. Refactor the existing candidate selector selection code and preemption rules to the new API and see if all unit tests and all functionality can be achieved with this API. Then we are thinking about making the API external, and as a step 3 or 4, implementing more selectors and allowing preemption limiting. This will obviously not happen within a single Q release. Inside of Google, we are staffing this effort. The effort will start obviously with the CAP so that everyone in the community will be able to express their questions, concerns, ideas, or veto it if the thing doesn't make any sense. After CAP, we'll start with step 1. Hopefully, that will fit within .20 release timeframe. After that, step 2 will be started. If we get very lucky, maybe 0.20, but more likely will be like 21. That's more or less it. Any questions, comments, concerns?
Just can you share the stock in the agenda, the slide deck?
Okay. Yeah, sure. I will share it.
Thanks for presenting. That was awesome.
Welcome.
Cool. Is there any topics from anyone else? If not, we can probably wrap up. I see Yuki. Go ahead.
Yeah, just for your information. So we I and Mihao will we have a meeting track in KubeCon Yokohama, Japan this month. So if anyone attend the KubeCon Yokohama, let's talk about the Q and batch working group, something else. Yeah, that's it.
Sounds like fun. Cool. All right. Thanks, everyone.
One more question, maybe quick. What about KubeCon NA booth staffing? Do we have the booth approved?
Oh, I haven't received any emails yet, but I'll definitely let everyone know when I do. I can look at the dates of like when they come back with booth staffing, but the plan is to combine WAS and Q to have critical mass so that could just be staffed. And also it's like more fun hanging out when like because we're all in the same domain, like scheduling. So that's like the current plan. Did Kevin hop off? Okay, yeah. And then also on Thursdays is like the workload aware scheduling meeting if people also want to attend that. I think it's in like 2 hours. Cool. All right. And then yeah, in terms of staffing, I guess when the booth stuff does come out, I can ask manager Mihao if he wants to lead that or we can also just copy whatever his docs used to be. Sumantha, I see your comment. You're saying, yeah, as a new contributor, it's like difficult to follow some of the discussion, newcomer meetings. If you're wondering if there's any newcomer meetings or onboarding sessions, yeah, I feel like contributing to Q can be difficult. So my advice is keep trying. Keep attending, keep trying, and then we're super responsive on the working group batch Slack channel. And then yeah, Andrew, I think were you a new contributor? I mean I noticed you in the past couple of months, so to me, but I've been seeing you contribute a lot, along with someone else that's I think on this call, Shrisha, making some PRs. So maybe you guys can like DM each other as well. I try to post things that people can take up for grabs in the working group bat channel lately and help like push them along. So just keep a lookout for the Slack channel. Um, cool. All right. Thanks everyone. See you in 2 weeks. Awesome. Bye.
Yeah,
Yeah,
bye.
see you.
Thanks.